Hello everyone. Welcome to the first recitation of the course Introduction to Deep Learning for Spring 2019 semester. I'm Simran Chaudhary and I'll be your instructor for part 1 of this recitation. In this recitation, we'll be familiarizing ourselves with different Pythonic constructs and techniques that are used extensively for data loading and model development using DL frameworks. Before we deep dive into this, here's a list of prerequisites that we expect you to fulfill in order to be successful in this course. First is basic knowledge about Python syntax and how to implement various programming constructs like functions, for loops, etc. in Python. Secondly, you must be able to set up your own development environment, which in this case is setting up your virtual or Conda environment. Installing different versions of Python packages through pip and conda will come in really handy throughout the course. This can be referenced easily through online resources. Lastly, basic knowledge of object-oriented programming concepts like classes, member functions, variables, etc. If you seem fairly confident about your skills in these aspects, you can move on to what to expect from this recitation. Firstly, you learn how to import packages in your program, which mainly includes essential packages for your deep learning modules like PyTorch and TensorFlow. Secondly, what are the different formats in which data is stored and how they're streamed efficiently in Python. Thirdly, data containers, which are merely a representation of the data that has been loaded into the program, into the memory. Then further data wrangling and batch operations that operate on these data containers to modify or filter the data and do that efficiently. Iterators and generators are Python programming constructs which are used by these deep learning frameworks for data loading and data processing. Lastly, how to debug your code in case you're stuck at some point. So let's deep dive into these concepts without further ado. First and the most elementary thing is modules and packages in Python, which is importing library functions or using the pre-existing code in certain packages. Syntax is just import and module name. Suppose you've created your own module and you need to load a specific feature of the module. You can do that by this syntax saying from module name, import function or class name. If you're new to Python, I would recommend going through the Python standard library, specifically Python runtime services and operating system utilities, because it helps you interact better with the underlying file system and issue commands to your file system. The other modules that you'll be frequently using are NumPy and Matplotlib. NumPy is for housing data, storing numeric data, and Matplotlib is to visualize that. However, TensorBoard is more commonly used for the same purpose now, and PyTorch support for it has also been developed with the name TensorBoard X. We would have a tutorial on that later, but for now basic use, you can use Matplotlib. Lastly, PyTorch and TensorFlow, which are the deep learning frameworks you'll be using throughout this course, but you'll be encountering them later, so we shall not deep dive into them in this recitation. Essentially, the aim of this recitation is to equip you with the techniques to load the data from the data source and to manipulate or filter out the data to suit the format required by these deep learning models. So if you're new to Python, please pay very close attention to the techniques that are being used here, because in Piazza, we'll be just mentioning about these techniques, but you'll be expected to know the underlying implementation, which you can learn from this recitation. So firstly, data sources and common data store formats, which is how do you load the data from a certain dataset file. Typically, your numeric data is stored in a .npz file, which is used to store an array of numbers. Multidata, like rows of each sample in a dataset, which can be a combination of strings, numeric data, enum, etc. This type of data is stored in CSV files. Plain text data in simple txt file format. Large data sets, when you're storing heavy data like videos, then HDFI format is used for that. We'll be dealing mostly with pickle and CSV file formats. Pickle is a way to serialize or deserialize a Python object. For deep learning modules, it is particularly useful if you want to store an intermediate state of your program and do not want to lose that to be able to load it later. So supposing you just import the pickle module with the import statement here, and then you define a dictionary like this. What is a dictionary? We'll come to that later. So this is your object, and you simply pickle dump it into the file called store.pkl, and then you can retrieve the same object, same data into this new object called obj2 with a simple pickle.load command, and you see that the same data has been copied into the new object. So this is just a way to serialize and deserialize your data. Furthermore, the other format is CSV. This syntax is for opening a CSV file, which is also in general used for opening any type of file format in Python by specifying the mode you want to open it in as read or write. This simply creates a file object, and by passing out which is with this file name data slash iris.csv. And then we are also using a reader, which iterates over on iterating through which we can print out each and every row into the um, console, as you can see. So this is a general syntax to read the data from a data source and load it into the memory. Also, I would like to mention the importance of pickle and serializing and deserializing Python objects in general. For example, when you're trying to store your deep learning model's weights and parameters values while running the program, so that if your program ends unexpectedly at some point, maybe say 2 hours later, you still have the last state to retrieve from easily and continue your model training. So this will be very useful when you have to do your assignments, and which take like hours to run, maybe like overnight. You will want to save the weights every now and then so that you can retrieve from any point whenever you want to. So once you've loaded the data into the memory, how is the data stored into the memory? So data containers are the answer to that question. Python offers different kinds of data containers. There is a list, which is a generic container which stores data by indexing them numerically. So to access data from a list, it is done similar to arrays in other programming languages. Tuples are used to store pairs of values, like for example, name and age of a person, and it stores them as immutable lists. So, which means that once you've created a tuple, you can store as much data as you want, but you cannot modify or delete elements in the tuple. Dictionaries store key value pairs like key unique ID of a dataset row could be a key, and its description could be the value. Sets are nothing but lists with all unique elements. So majorly we'll be focusing on lists and tuples because that's what you'll be using extensively in the assignments. So lists can be homogeneous, having same kinds of elements, or heterogeneous, having different kinds of elements, numbers, strings, or anything. So what is the most common data container that you'll encounter? That is a tuple list, a tuple list, or just a list. A tuple list is simply a list of tuples where a tuple could look like this, denoted by curved brackets, and they will have the same number of elements, and each tuple and in each tuple and have the same data types. So this consistency is maintained in a tuple list. This format is encountered a lot in later stages, wherein you'll be loading into a model a batch of data, that is a list of tuples, where each tuple represents a training instance, wherein a training instance can have a list of features. So this could be feature 1, feature 2, and so on. And this whole thing would be one training instance. Now, what are the operations that you can perform on these elements? So let's say I had a homogeneous list and I multiply it by 2 like this. It's not that all the elements will be multiplied by 2 as you would expect. Instead, it just deprecates the list and appends appends it as it is after. So the list 12 to 85 is appended as is. So you get a new list with double the length. And when you add two lists, it just appends one list to another. These are the arithmetic operations that are available and very common, like sorting and finding a sum, finding maximum and minimum, which do the work as the name says. The other operations are filtering operations. For example, I want a certain subset of elements in a list. Then how do I extract these? So these are the two ways. One is where I know the index of that element, and this index-based method is called slicing and dicing. And the other is where I have a condition, and the element that satisfy this condition are going to be extracted. This condition-based method is called list comprehension. So firstly, slicing and dicing is done in the following way. Yeah, it works like I know the start index and the length or number of elements which I want to extract, which is the same as end index plus 1. And I also know the step size, which means how many elements to skip in between, one meaning choosing continuous elements. So in this example, you can see if I skip the start index, it defaults to 0 and it gives first 5 elements of this list. And in this example, start index is -1, which means index 1 in the reversed order of the list, which in this case would be 85. Then step size, step -2 would mean that skip 2 elements in the reversed order. So uh, -2 would be 70. -2 will get you 166. So, and after that 78, and after that 45. So this is what you get until the element 0. This is the output. So these are the methods of extracting the elements when their indices are known. For extracting elements based on condition, the method is called list comprehension, and the syntax looks like this. So you have transformation, iteration, and filter. So iteration is where you go through each element in the list. Filter selects which elements to keep, and transform tells you what to do with that element. So for no in homo list, take elements which are uh, greater than 50 and store them in the list res. So why is list comprehension required? The same thing could have been done by using a normal for loop like this, in which you just go through each element, go through each index, the size of the list, and append it to the new list. Turns out list comprehension is relatively faster than simply appending it, which is significant when you're dealing with billions of data samples. So in this case, you see it's almost half the time it takes for it to do using list comprehension. Another use case where you'll be using list comprehension is here. So I've written a data loader in this get data function, which is written externally, which you don't need to worry about right now. So this loads the data in the batch data set, and each row of which is a tuple of complex objects like this. So utterance is an array or a list. Size, utterance size is an integer. Transcripts is the text, the letters that are corresponding to the utterance, which are generated from automatic speech recognition system. So the data is like audio, which is recorded as the frequency of the audio in frames per second, and utterance size tells how many frames are there. So transcripts is corresponding letters for that audio, and transcript size is total number of letters in this audio piece. So in this array, each row represents a phoneme. As you see here, this particular row represents one phoneme. A phoneme is like an atomic element of speech, like letter is for text. So multiple phonemes together can possibly make up a letter or a word in text. So each phoneme is made up of multiple frames. This value represents the frequency at that frame. And so this is the utterance size. These are the transcripts and the transcript size. These basically corresponds to each letter in a dictionary, where so that's why the values are ranging from 0 to 25. Now, these are the operations that can be performed on the batch dataset. Suppose you want to sort it based on the utterance size. So they provide the key as a lambda function. Here, every x will represent the tuple in the list, and I want the second element of that tuple to be used as the key. Second element is the utterance size itself. Similarly, max operation is to find the transcript with the max length. So the transcript size is basically the third element, the fourth element in the list, and that is being used as the key here. So I use x of 3 as the key to find the record with maximum transcript length, and I also return the length of that transcript by using this third by indexing by 3. Lastly, list comprehension, as I was saying, is very important. So suppose I want to extract just the transcript and their corresponding size from each record. This list comprehension will do that. Also, you can carry out certain manipulations in the data set on each and every tuple. Say, instance represents a tuple and I want to transpose it uh, by using the manipulation function. Then every transcript value in that instance is transposed through data through this line and stored in this variable called padlen. And I create this array, and then the transposed version of this looks like this, which if you compare from this one is the transposed version. So these are the operations that you'll be doing in the preceding assignments. So keep these tricks in mind. Also, there's a concept of classes in Python. So in further assignments, the most important usage of classes would be in making iterators. In PyTorch, you have the concept of dataset class, which is how do you load the data and iterate over your data. This dataset class of PyTorch does not deal with lists, but instead uses iterators and iterable, which essentially is an abstract data type customized by you, which maps to a container in Python, and every iterator needs to have these three functions. Whenever we ask you to create in Python a container, an iterator, you should have these three functions outlined. So this is useful when you pass 2, 3 sources of data from different sources and the ground truth labels coming from another source. I can store them in my iterator like this, and whenever we're asked to get the item for any index, say third index, which would be the key, the index would be the key here, then I can return the elements at corresponding indexes of the data and the label as a tuple and return that. The length function here just tells me how many elements are there in the iterator. So when you've asked to create or override the dataset class of PyTorch, as you will be asked later, you will need to implement these three functions. The other way of doing so without creating a class, you can also have a function instead of a class, which in Python is called generator. So generators do the job of keeping track of the state of the iteration as to which index was accessed last time and which one shall be fetched next. So generators keep track of that if data is being iterated sequentially. How to write generators? Their syntax is simple, like a function in Python, where instead of a return statement, in the function, you have a yield statement. So like in this case, I have a pairwise generator which takes in a data source and it iterates through the data source and yields every consecutive element. So in this example, I instantiate the data set, which is defined over here, and pass this data as the list to the input, as the input to the pairwise generator function. So when I iterate in this, it returns the I and I plus 1 its element together, say number 1 and text 1 here, and so on. So I get from a list individual tuples returned here as is. So these are the two ways of iterating, either through a class with length and get item functions or through a generator. Lastly is debugging in Python. This is a helpful tip when you don't know what state your internal data is, since there's a lot of data that you'll be handling. You can start off with import PDB, which is the interactive Python debugger module, which is similar to GDB and GCC compiler. So to set a checkpoint, you simply do a pdb.setTrace and run the code. So when the interpreter reaches this line, it will pause basically, and you can use different PDB commands to trace the execution, such as step into a function or continue execution and so on. You can also see values of variables at that point to confirm if your code is correct. This is a better way of finding bugs rather than having print statements all over your code. So for example, if I run this, I get the PDB debugger stops in this line. If I print what the input data looks like, this is what the input is, then I will say just continue to the for loop, and it pauses at the yield statement, and I say just continue. It prints one, which is the first yielded pair of elements returned from the generator. Then if it is back in the for loop line, so if here I check what ELT is, it will be 1. And if I step into the for loop line and go to the yield function and check what the input data is right now, the ith element of the input data, it'll be 2. So that's because the generator hasn't yielded the new index data yet. So I say continue, and it yields the next row, the next tuple of elements, and so on. I can just say continue to the remaining statements, and it returns 3 and 4. So by this, I can see the whole execution of the program, which all statements are, how are they modifying the data variables, and possibly find a bug in your code. So this was the overall recap of Python basics that will help you get started. The next half of the tutorial, covering some NumPy essential commands, will be covered in a separate video. Do check that out as well. If you have any questions, please post on Piazza. Thank you.